welcome to another GCSE Computer Science video with me, Mr Goff, from mrgoff.com. Today's video will focus on factors that affect CPU performance. The performance of the CPU on a computer will greatly affect the experience a user has when they're using that computer. When choosing a new computer and comparing processors, the factors you should consider are clock speed, number of cores, and cache size. Clock speed is the number of instructions a processor can handle each second. It's measured in hertz, and most modern processors are between 2 and 5 gigahertz. This means they can perform between 2 and 5 billion instructions per second. A higher clock speed means a faster running processor. The number of cores a processor has means how many separate processors does it have available. A single core means a single processor. A dual core means 2 processors. A quad core means 4 processors. Increasingly, machines are being sold with 6, 8 and 10 cores. A single core processor running at 2 GHz can handle 2 billion instructions a second. A dual core with its multiple processors can handle twice as much, 4 billion instructions per second. Some programs are written to take advantage of multiple cores, but not all of them. It's harder to write a program that takes advantage of multiple cores. If a program is not written to take advantage of multiple cores, it will run fastest on whatever processor has the highest clock speed, regardless of how many cores that processor has. The cache is a small amount of very fast storage on or very near the CPU. It stores recently used and frequently used instructions. The control unit automatically checks the cache for instructions and data it's looking for before requesting them from RAM, which takes longer because RAM is further away. If data does have to be collected from RAM, a copy is stored in cache in case it's needed again in a short space of time. As more cache means fewer trips to RAM, which takes longer, more cache means a better performing CPU. There are generally 3 levels of cache within a CPU. Level 1 cache is the smallest size, it's the most expensive, but it's the fastest because it's closest to the processor. Then it goes up to level 2 cache, and finally level 3 cache. Even though it is slower than level 2 and level 1 cache, level 3 cache is still considerably faster than fetching something from RAM. In a multi-core computer, generally level 1 and 2 cache are stored independently on each core, while level 3 is cache that's shared between each of the cores. You could be asked in an exam to compare the performance of different computers based on the information about their CPUs. If we had the 3 computers below, the things you'd be expected to pick up on would be: computer A and C can both complete a total of 6 GHz of instructions, while computer B can only complete 2.8 GHz. Computer A has more cache than computer C, so would ultimately be faster for programs that perform a lot of repetitive steps. If a program was not written for multiple cores, it would run fastest on computer C, which has the highest clock speed. There are also other factors that can affect the overall performance of a computer beyond the CPU. Things such as RAM. More RAM can allow more programs to run effectively at the same time. Another factor that might affect overall performance is the hard drive type. Data can be loaded from an SSD far quicker than it can be loaded from a hard disk. That brings us to the end of this video on the factors affecting CPU performance. Join me in the next video when I'll be looking at embedded systems. Use the resources at mrgoff.com to help you revise computer science. And until next time, it's bye for now.